Lesson: Common attack vectors in blockchain and AI systems. Blockchain and AI systems are at the forefront of modern technology, offering unprecedented capabilities across a wide range of applications. However, with great power comes great responsibility, particularly in terms of cybersecurity risks. As these technologies become increasingly integrated into critical systems and processes, understanding the common attack vectors is essential for professionals tasked with mitigating risks. This lesson delves deeply into the various attack vectors that threaten blockchain and AI systems, providing actionable insights and practical tools to help professionals effectively manage these risks. One of the primary attack vectors in blockchain systems is the 51% attack, where a single entity gains control of the majority of the network's mining power. This allows the attacker to double spend coins and potentially disrupt the blockchain's operations. To counteract such threats, professionals can implement decentralized mining pools and promote the diversification of mining hardware. Additionally, employing consensus algorithms like proof of stake can reduce the risk of such attacks by making it more costly for an attacker to gain control. Another prevalent attack vector is the smart contract vulnerability. Smart contracts, which are self-executing contracts with the terms of the agreement directly written into code, can be exploited if not properly audited. Tools like MythX and Oyente can scan smart contracts for vulnerabilities before they are deployed, allowing developers to patch any issues proactively. A notable example is the DO hack in 2016, where a vulnerability in a smart contract was exploited to siphon off millions of dollars worth of cryptocurrency. Comprehensive code audits and utilizing formal verification methods can significantly mitigate these risks. Phishing attacks also pose a significant threat to blockchain systems. Attackers often use fake websites or email communications to trick users into divulging private keys or seed phrases. Implementing multi-factor authentication and educating users on recognizing phishing attempts are effective strategies to combat this. Furthermore, browser extensions like MetaMask can provide a secure interface for interacting with blockchain applications, thus reducing exposure to phishing sites. Turning to AI systems, adversarial attacks represent a significant risk. These attacks involve subtly manipulating input data to deceive AI models. For instance, altering a few pixels in an image can cause a machine learning model to misclassify an object, which could have serious implications in security-sensitive applications such as autonomous vehicles. Techniques like adversarial training, where models are trained on perturbed data and using robust optimization frameworks, can help bolster the resilience of AI models against such attacks. Data poisoning is another critical attack vector in AI systems, where attackers inject malicious data into the training dataset to skew the model's predictions. To mitigate this, professionals can utilize data validation techniques and anomaly detection tools to identify and filter out suspicious data points. Additionally, employing federated learning, where models are trained across decentralized devices using local data, can reduce the risk of centralized data poisoning attacks. The AI supply chain also presents vulnerabilities, particularly through the introduction of backdoors during the model development process. Ensuring transparency and accountability in the AI supply chain is crucial. Professionals can implement tools like ModelChain, which leverages blockchain technology to secure and verify the provenance of AI models and datasets. This can help ensure that models have not been tampered with during development or deployment. In both blockchain and AI systems, insider threats remain a persistent challenge. Employees or contractors with access to sensitive information can intentionally or unintentionally cause significant damage. To mitigate insider threats, organizations should adopt the principle of least privilege, ensuring that employees have access only to the information necessary for their roles. Regular audits and monitoring of access logs can help detect and respond to suspicious activities promptly. Finally, regulatory compliance is a crucial consideration in managing cybersecurity risks in blockchain and AI systems. Regulations like the General Data Protection Regulation and the California Consumer Privacy Act impose strict requirements on data privacy and protection. Professionals must ensure that their systems are compliant with these regulations, utilizing tools like privacy impact assessments and data encryption to safeguard user information. In conclusion, understanding and mitigating common attack vectors in blockchain and AI systems is critical for professionals tasked with ensuring the security and integrity of these technologies. By leveraging practical tools, frameworks, and strategies, professionals can effectively address real-world challenges and enhance their proficiency in managing cybersecurity risks. As the landscape continues to evolve, staying informed about emerging threats and adopting a proactive approach to risk management will be essential for maintaining the trust and reliability of blockchain and AI systems.